they ask 3 times. So possibility of asking any of the things, that one. So let this be. Let this be V naught. Okay, this is at t equals 0. The switch is closed. You have to calculate the switch is closed at t equals 0. You have to calculate the maximum current in the inductor, frequency of oscillations, then maximum charge across the capacitors. If you want, you can find out that also. At t equals 0, switch S is closed. Find the omega and I max. How capacitor they are in series, no effective capacitance straight away. Nino 2, so they're in series, so effective capacitance 3C by 4. So what is omega? Omega equal to 1 by root of L 3C by 4. Or C dash, what is C dash equal to? 3C into C by 3C plus C. Omega equal to 1 by root. C dash is 3C by 4, no? So 3 LC by 4. They're in series. I'm directly going for that. No, after this. How to get that I max? So again, what is the basic idea? If there's a point A, there's a point B, and there's a point P, no? Just now, previous problem with one capacitor I discussed. Now both the capacitors are initially charged. There is only difference here, nothing big. So there's a point A, there's a point B, there's a point P. There's a capacitance C. Now what is the basic necessity condition? When both the capacitors, current will be maximum when potential difference across the coil should be 0. Finally, what will happen? We don't have anything, no? Because that's the way the polarities are given. I'll assume like this: polarity is plus minus, plus minus. Then what's the potential drop? Should be same. How? Any reason for that? Because current through the coil will be maximum. Current through the coil will be maximum when VAP equal to 0. For this to happen, I can also write VAP is equal to VBP. Just a little bit, earlier problem, the inductor was on top, capacitor below. So there's the equation. So now write this set of equation. What is VAP? Potential difference. So there'll be some charge, no? In this. So what is the charge? CV it will be by C. So some calculate the potential difference across this one, VAP, then VBP. Let V be the potential difference we are taking. Both will have same charge or different charge. I think charges should be different, no? Because capacitance are different. So here you put it charge Q1 minus Q1, Q2 minus Q2. So what is VAP should be equal to? I know negative, or okay, some of you are asking negative. So minus Q1 by C minus Q2 by 3C. So from here, Q1 equal to Q2 by 3. Equation 1. Then charge of these plates must be conserved. Charge of these two plates must be conserved. What was earlier charge? CV naught. Charge of LO plates must be conserved. So therefore this will be minus CV naught plus 3C 2V naught should be equal to Q1 plus Q2. So two equations, two unknowns. Solving this, I'll get Q1 and Q2. After getting Q1, Q2, so let me continue further. This will be 6V naught. This will be 5CV naught. Q2 equal to 3Q1. So therefore, Q1 equal to 5CV naught by 4. Value of Q2 will be 5CV naught by 12. Now we have Q1 and Q2. Let's write energy equation. Overall energy will be conserved. Not which energy here it is. Electrical energy, better you can call. Together electrostatic and magnetic, you can call electrical energy. So initially C V naught square by 2, 3C2 V naught square by 2. Same problem, just with the different values, I'm repeating it here. Energy CV naught. Three C 2 V naught whole square by 2. Q1 square by 2C. Q2 square by 2 into 3C plus L I max whole square. Now you can ask questions why you are not writing I max equal to Q naught by omega. Can I use that formula? Why can't I use directly this? Why am following this lengthy method? What was the initial charge of system? I know that what is that initial charge? We are not very sure how much it is, because two capacitors are there. Getting that? That's why we are using this method. So when to use this formula? Only when inductor, one capacitor there. Okay, this is more safer side. That's why I'm asking you to do analyze. Check it. Nothing wrong, no? So you do one thing. Sir, I'll write Q naught omega. You solve this and compare. What to write Q naught, we don't know here. This is no problem with the equation. I max equal Q naught omega. There's no problem with this equation. But what is Q naught? I don't know here. So Q naught means I'll add up charge. So charge of which plate? Charge of this plate, will you take it? Or charge of this plate, or resultant charge of these two plates? We are not very sure, no? So therefore, this is a more preferable method. So when to use this formula? Only when one inductor, one capacitor. So when you have two capacitors, I think better to avoid this. These are some small things which you have to make observation. The set of formulas what we have, what are the limitations for that? the value, anybody IMAX? It is showing like this, 3V0 by 2. This much of answer is given. Verify this. Okay, this is overall about the general idea. Tomorrow, what happen? We will introduce mutual inductance. We'll introduce different types of application problems. We'll go beyond certain things. I'll introduce a cell.
Inside root 3C by L, sir.
3C by L.
Yes, sir. 3C by L.
Okay, here C will come.
Sir.
Okay, fine. Again, dimensions will mention. Tomorrow, what we do? If I bring resistance, if some resistor is brought here, if one cell is brought here, then if I bring one more loop, mutual inductance comes into picture. What conditions are to be followed here? That will be like a little bit higher application problems that we'll concentrate on tomorrow. Fine. And tomorrow what we do? Till now today what happened? We just energized circuit using capacitor. Tomorrow what happen? If I feed energy through inductor, it's very difficult. On paper we can check it. I'll give energy to capacitor. Today what we did, capacitor. Tomorrow what happen? We'll give energy to inductor. We'll give energy to both capacitor inductor. Then how oscillations are set up. Then mutual inductance. Then one cell, one resistance. Then if I remove slab from it, what changes will come? If I remove some rod